All right, for this lesson, we're going to be talking about different ways of factoring a quadratic. So when we look at quadratics, we are talking about that exponent of 2. And there's different, depending on how many terms it has, depends on how we would want to factor that. So what does factor mean? Well, factor means that you're basically breaking down the polynomial into smaller expressions. So you're going to be breaking down the polynomial into smaller expressions. Now we're going to want to do this because eventually when we get to the solving quadratics, you're going to have to do some factoring in order to get those pieces. So when we talk about breaking it down, that means that we're undoing the multiplication. So if something is being multiplied, that means we're undoing that multiplication. But the one thing and the most important thing really is you always have to check for a greatest common factor. There may not be one, but you need to check for one. So let's just kind of review what greatest common factor is. So greatest common factor is the largest number that you can basically take out of all the pieces, whether that be the numbers and the variables. So when I look, I should be able to see that I have 8 and 4. So the largest number I could divide out of 8 and 4 at the same time is 4. Now, I don't have a variable on this 4 term, so I can't take the m out, okay? I have to have a variable, and they have to have the same amount of variables on both pieces. So my GCF is the number 4. So that means if I divide 4 back out, okay, so essentially what we're doing is we're going to say 8m divided by 4. So that's going to leave me with 2m. And then we're going to be dividing 4 out of 4, and that leaves me with plus 1. So if you notice, what originally would have done is we would have distributed that, which gave us the 8m plus 4. So we undid that distribution, that multiplication. All right, so looking at number 2. So for number 2, let's start with the numbers. So I have 9 and 21. So the largest number that I can divide into 9 and 21 is going to be 3. And then I have variables this time. So this one has 2 p's, because remember p squared is p times p. And then I have a p here. So I can definitely take 1 p out of each term. So we're going to take 1 p out of each one. And my GCF is going to be 3p. So we're going to take 3p out, which means we're going to divide it out into the problem. So we're going to divide 3 and p. So 9 and 3 is going to give me 3. I had 2 p's divided by 1 p. That leaves me with 1 left over. So this is going to be 3p. So we're going to do the same thing here. We're going to say 3 and p. So we're going to say 21 divided by 3 is going to be 7. I had 1 p in that problem, and I took 1 out. So again, just remember when you're doing the variables, this is the same thing as p times p. So we're able to take 1 out of each term. We can't take more than 1 because we have to take the same amount. All right, so for the next one, I have 5x cubed and minus 10x. So just as a reminder, this is x times x times x. All right, so I have 5 and 10, so the largest I can divide out of 5 and 10 is 5. And then I have 3 x's, and then I have 1 x, so I'm able to take 1 x out of each one. So my GCF for this one is going to be 5x. So if I divide 5x back out of each term, that's going to undo that multiplication. So I'm going to divide 5x here. So 5 divided by 5 is 1. Now I had 3 x's, but I took 1 out, so that leaves me with 2 of them. So I don't have to write the 1 in front. I can, because if we did 5 divided by 5 is 1, but we should automatically know that any variable has a coefficient of 1 if we don't see it. So then we're going to divide negative 10 and 5. So that's going to give me negative 2. And then I had 1x, and when I divided that, I took an x out, so I'm left with none. All right, so this time we got 3 terms, so we've got to make sure whatever we take out all 3. So I have, in this problem, I have a 5, a 10, and a 5. So I know my GCF is 5. However, This, because it's in standard form, which means all the variables are going down from least to greatest, I have a negative in front. So I want you to get in the habit, whenever you have a negative coefficient, a leading coefficient, go ahead and take the negative out with the GCF. It's going to be helpful for you later on. So I don't know if you want to make a note here, but remove negative with GCF. Okay, so whenever I have a leading coefficient that's got a negative, I'm going to take that out with the GCF. And then I have, here I've got 3 m's, because it's 3 to the third, or m to the third power. I've got 2, and then I've just got 1. So I'm going to take 1 m out of all 3 terms. So my GCF, we're going to make that negative 5m. All right, so if we take negative 5 and m out of each term, that means we're going to divide it out. So again, we're going to say negative 5 divided by negative 5, which is going to make that into a positive 1. And again, that's going to be more helpful for us later on. So I had 3 m's and I took 1 out, so I'm left with m squared. And then negative 10 divided by negative 5 is going to be plus 2. And I had 2 m's, but I took 1 out, so I'm left with 1. Negative 5 divided by negative 5, or 5 divided by negative 5 is going to be negative 1. And I had 1 m, I took 1 out, I'm left with no m's. All right, and this last GCF. So I've got, for my numbers, I've got 6, 4, and 2. So the largest number I can divide out of all 3 of them is 2. And then for my variables, I've got 3 x's here. I got 2 x's here. And then I've got 1. So we're able to take out 1 x from each term. So our GCF for this one is going to be 2x. So if we divide 2x out of each term, we're going to factor that GCF out. So 6 divided by 2 is going to give me 3. I had 3 x's, but I took 1 out, so that leaves me x squared. And then 4 divided by 2 is going to be 2. And then I had 2 x's, took 1 out, I'm left with 1. And then 2 divided by 2 is 1. I had 1 x, but I took that x out, so I'm left with no variables on that last term. All right, so as just a review for GCF, I hope that we need to make sure that we remember this every time we factor. Even if we don't have one, we always need to check. So the next thing that we're going to talk about is factoring with 2 terms. Now, even when we have 2 terms, we always want to check for a GCF before we get started. Now, when we do 2 terms, there is a method or a technique called difference of squares. So this difference of squares is called difference of squares for a reason, because they have to have certain criteria in order to factor it this way. So when I have difference of squares, okay, first thing that you got to make sure of is difference of squares can only happen when I have 2 terms. So 2 terms means 2 pieces, whether it be variables, numbers, or a combo of both, separated by addition or subtraction. So I need 2 terms. I have to have perfect squares. So perfect squares are those numbers where it's like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so forth. And we'll go over a few of those in a minute. And the last thing is called difference of squares because it has to be subtraction. Okay, it has to be subtraction. So it can only be 2 terms. It has to have perfect squares, and it has to be subtraction, which is why it's called difference of squares. Now, just to make a note, this technique that we're going to talk about does not work with sum of squares. This is only a technique that works. It's like a shortcut for factoring. The sum of squares is non-existent. It does not work when we have addition. It has to be difference. So how does it work? So when I'm looking at a problem, if I have two terms, so this is my first term, this is my second term, and I have both of them as perfect squares, then I can break those squares down, okay? And I'm going to break them down, and I'm going to take the square root. So if I take the square root of a squared, I have a. So the a that we're talking about, that's going to be put in the first part of the term, because a was in the first part of the term when we had, or the expression when we had it initially. Okay, so we're going to break that down by taking the square root, which is why it has to be a perfect square, so we can take the square root of it. So then we have our b squared. So b squared, whatever that may be, is a perfect square. So we take the square root of that and we break it down into two b's. So we have a b, and we're going to put that in the second part because it was the second term in the problem. Now, the last thing that's super important is the fact that it needs to be one positive and one negative. That's the only way that this works out, because when we multiply it out, we need to have a positive and negative so those middle pieces cancel and leave me with two terms. Okay? So, with that being said, let's talk about our perfect squares. So, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared, 25, 6 squared is 36, 7 squared is 49, 8 squared is going to give me 64, 9 squared is going to give me 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is going to be 169, and then 14 squared is going to be 196. Now these can keep going, but these are just like the top ones that we see the most. So what we're going to be looking at, so when we look at number 6, I have two terms. My first term is going to be the 49x squared, and my second term is the minus 1. Now, if we look at this, first thing I'm always going to check for is a GCF. Well, 49 and 1, obviously I can divide it by 1 and make the 1 GCF, but I don't want to divide it by 1 because that's not going to change anything. So, I have subtraction, I have two terms, and the last question is, are they perfect squares? Well, 49 is a perfect square because 49 is technically 7 squared. 1 squared is a perfect square because that's 1 squared. Now, the last thing comes down to the variables. So, any even exponent is a perfect square because I can say x to the 6 is the same thing as x to the third times x to the third. I can break it down into halves, which is what you're doing when you multiply exponents. You add them together. So, how does this work? We're going to create two parentheses, one plus and one minus. So you got to remember that. You always have to have one plus, one minus. I don't care if you put the minus first. It doesn't really matter. But what we do need to do is we need to take 49x squared and we need to take the square root of that. So if we take the square root of that, that's going to leave me with 7x. So the 7x, because the 49 was in the first term spot, is going to go in the first term spot in both parentheses. Then we're also going to take the square root of 1. So the square root of 1 is still 1. That's going to go in the second spot. Okay. Now, why does this method work? Because if I were to multiply these two things back out, so I'm going to just kind of show you my little box and multiply it out. So we got 7x and 1, 7x and negative 1. So that's going to be 49x squared. That's going to be negative 7x. This is positive 7x. And this is negative 1. And these two are going to cancel each other out, which is why we have to have a plus and a minus. So because they cancel each other out, I'm only left with 49x squared minus 1, which was the original problem over here. All right, so for number 7, we have two terms, and this time I have addition here. So it doesn't look like it's difference of squares. However, I need to check for a GCF. So if I look for a GCF, I have negative 50 and 8. So if I'm thinking about what's the largest number that I can divide into both of those, so I definitely could divide 2. can't divide 4, can't divide 8. So I do have a GCF of 2. However, we said just a second ago that if I have a negative as my leading coefficient, I want to go ahead and take that negative out with the GCF. So if I say negative 50 divided by negative 2, that's going to leave me 25, positive 25, and the x squared because we weren't able to take out any variables. Then I'm going to do 8 divided by negative 2, which is going to leave me with negative 4. And once I do that, I now have in the parentheses a difference of square problem. If you look, I now have subtraction. 25x squared is a perfect square, and so is negative 4. So if I take the square root of my 25x squared, that's going to leave me with 5x. So when we write this out, that GCF does not go away that we took out. It's still part of the problem, okay? So we're going to do 2 parentheses, and we're going to do 1 plus and 1 minus. So the first one we got was a 5x. That was in the first term spot. So we're going to put 5x and 5x here. And then we're also going to take the GCF of 4. So the GCF of 4 is going to be 2. So that's going to go in the second spot of both parentheses. And again, if I multiply this out, I could distribute this in, get a different numbers in that term, and then multiply it, and it would give me this same original polynomial or quadratic that I had. All right, so for number 8, again, we always check for GCF first, and I should see that I have 144 and 16. 144 is divisible by 16, so 16 would be the largest number. So if I pulled up Desmos, just to kind of check it out, I can see 144 divided by 16 does in fact give me 9. Now, that means that I'm going to divide 16 out of all of the terms. So if I do 16 here, that's going to be 9y squared. And then 16 divided by 16 is going to be minus 1. Now, what we should see is after taking that GCF out, we now have the difference of squares inside the parentheses. So the 16 is not going to go away. It's still going to be part of the problem, but I can now computate the difference of squares for each term. So I have 9y squared. If we take the square root of that, that's going to give me just 3y. So remember, when you make your 2 parentheses, you're going to do 1 plus, 1 minus. And it doesn't matter if you put the plus first or the minus first, as long as there's one of each. So we're going to put 3y in the first term spot in both parentheses. We're also going to take the square root of 1, and the square root of 1 is also going to give me 1. All right, so then for number 9. Now for number 9, sometimes it confuses students just because of the fact that they're so used to the variable being written on the first term, but it doesn't matter because they're still perfect squares. So do I have a GCF for this? So 49, we can't divide it by 9. We can't divide it by 3. So at this point, there's no GCF here. So we're just going to go ahead and look. We have 2 terms. We have subtraction. 49 is a perfect squared, and 9y squared is a perfect square. So we're going to do difference of squares. And when we write this, we need to make sure we get 1 plus, 1 minus. All right, so we are going to take the square root of 49, and the square root of 49 is going to give me 7. So 7 is going to go in the first place, in the first part of the parentheses, just like the 49 was in the first term of the actual expression. All right, and then we're going to take the square root of 9y squared, which is going to be 3y. All right, so once I do that and I get 3y there, we're going to be able to put that into the second part of both parentheses. So we have 7 plus 3y times 7 minus 3y. So don't change up the order just because the variable doesn't look right in the second spot or the second term. All right, so if we have two terms, always check for a GCF and then see if you have difference of squares. Now, if you don't have difference of squares and you're able to take out a GCF, then you can't factor any further. We do have some factoring later on that's like difference of cubes and all that, but for right now, we're just focusing on difference of squares. So, next thing is how to factor with three terms. So, three terms is that quadratic format that we've been looking at, that ax squared plus bx plus c. Now, I'm going to show you the slide, divide, and bottoms up method. And the reason I started doing this one is because there's all types of methods for factoring a trinomial. So essentially the formatting of finding the multiples of c to add to give me b, which is kind of how I set this table up over here, happens with any method, except for the fact that other methods you kind of got to do some GCF and writing it back together and GCF, and a lot of times I feel like students make little common mistakes with those. So I find that with this way, kind of like manipulating the numbers, the slide divide method, when you manipulate the numbers, it helps students eliminate some of those small mathematical errors. So, as like always, when I have a trinomial, which is three terms, I'm going to check for a GCF first. If I have a GCF, I take the GCF out, but the GCF is still going to be part of the final factored format. So, when I have a trinomial, it's called slide, divide, and I say bottoms up, but basically you're moving anything in the denominator up. So, first thing we're going to do is we're going to check for a GCF here. So my terms are 3, 7, and 4, and then I have 2 x's, 1 x, no x. So I can't take out an x, and then 3, 7, and 4 don't have anything in common other than 1. So the slide. The slide is how we manipulate our numbers. So we're going to slide the a. So remember the a is this first number right here, this 3. We're going to slide that all the way to the c and multiply them together. So once I do that, I'm left with x squared minus 7x plus 12. Now, why do we want to do that? Because it's going to help us actually figure out a combination of numbers, and those combination of numbers are technically the zeros or the roots or any of those things, but we just got to finish completing this whole process. So, a times c. So I need two numbers that multiply to give me 12, because it has to multiply to give me that a times c I just found. But those same two numbers have to add to give me negative 7. So I just kind of create a little organization chart. So with 12, I got like 1 and 12. So right now I just kind of focus on the positives, and then I think about, okay, can I make one of them negative or both of them negative to make it work? So 1 and 12, there's no way to manipulate 1 and 12 to add to get negative 7. So that's out. So then the next one would be 2 and 6. So again, there's no way to manipulate 2 and 6 and add it somehow, whichever one be negative, and get that. So that's out. So the last combination is a 3 and a 4. Now 3 and 4 have that possibility as long as I can manipulate the numbers a little bit by making one or both of them negative. So in order to add 3, or I wrote 7. In order to add 3 and 4 to get negative 7, I would need to make both of them negative. So I would need to make this a negative 3, and I would need to make that a negative 4. So negative 3 and negative 4 give me negative 7. So negative 3 plus negative 4 does give me negative 7. But if I make those negative, I got to make the other ones negative. I need to check that that works. So negative 3 times negative 4 gives me positive 12. So that is my combination of numbers. So what I'm going to do is I'm going to write 2 parentheses. I'm going to break the x squared down into just a single x into 2 parentheses. And what I'm going to do is I have a negative 3 right here. So I'm going to say x minus 3. I also have a negative 4, so I'm going to say x minus 4. Now, a lot of students try to stop here, but if we start the slide method, we got to finish it. So we slid the A to the C, but we did that to manipulate the number. Now we need to undo what we manipulated. So what do? We're going to divide the original A back into the two numbers. So we're going to say -3 divided by 3 and -4 divided by 3. So right here we slid the 3. So once we get our combination of numbers over here and we write it, we need to go back and divide it into both of them and get back to where we were originally. And simplify. So x minus 3 divided by 3, that's going to be x minus 1. Now, I cannot simplify 4 and 3. Okay, 4 divided by 3 is going to give me a decimal, and these are already in simple format. So I cannot simplify that 4 over 3 anymore. However, the last part to get it to look nice and pretty is to move any denominators up in front of the variable. That's the bottoms up part. So when I say bottoms up, that means anything left in the denominator, move it up in front of the variable in that parentheses. So my final factored form here is x minus 1, and then we move the 3 up, so that's going to be 3x minus 4, and that numerator stays there. And I could reverse the order if I wanted to. Both of these mean the same thing. Okay, that's that product property where if I multiply this one here, this one first, and then this one, or that one first, and then that one, it's the same thing. Okay? All right. So for number 10, we're going to go through this process again. So I have -x squared minus 8x plus 20. Now, right now it doesn't look like we have a GCF because I have a 1, a -8, and a 20. However, that negative in front is drawing my attention to the fact that I'm going to take that out as a GCF because I have that leading coefficient. So whenever you do that, whenever you have that negative, make sure you pull it out in front of the problem and divide it out. So -1 divided by -1 creates a positive x squared. A -8 divided by -1 is going to give me a positive 8x. And a 20 divided by -1 is going to be -20. And what we're going to do is that GCF is still part of the problem, but we're going to focus on the trinomial that's left in the parentheses that we need to factor. Okay, so that method that we talked about is slide divide. Now this one's going to be a lot easier because technically my A value is now a 1. Okay, so if I slide that 1 over to the -20, it's not going to change anything. We still have -1 x squared plus 8x minus 20. And if I have to divide, or when I go to divide, dividing by 1 is not going to change anything. So we actually are left with -20, and my B value is 8. So I need two numbers that multiply to give me -20. But those same two numbers, when added together, give me positive 8. So again, I start at the beginning, 1 and 20. 1 and 20, there's no way that you're going to get 8 out of that. So then we got 2 times 10. So I'm pretty sure I can make 2 and 10 work as long as we can get the negatives right. So remember, I can put a negative on the 2, I can put a negative on the 10, or I can put a negative on both. So we want a positive 8. So in order to get a positive 8, we're going to put the negative on the 2. So we have -2 plus 10, that does give me 8. And then we have -2 times 10. So -2 times 10 does give me -20. So that's going to work out for us. So that -1 doesn't go away. That's still the GCF is still part of the problem. So we're going to put it in parentheses and we're going to say x minus 2 because it was -2. And then x plus 10. Now, if we would go back to our method, the slide, we slid it over, then we divide. Well, technically, we slid a positive 1. So if we slid a positive 1, dividing by 1 is not going to change anything. So this is my final factored form. Whenever you have an A value of 1, all of those extra steps of the slide and the divide you don't have to wind up doing them because your final format it's not going to change anything if you slide a 1 and multiply it over or divide the 1 back out. And I'm just going to go back over here and I'm just going to box the correct answers for the notes. All right, so then we have number 11. Number 11, I'm checking. I have a 2, a -1, because that's technically a -1 and -6. So no GCF here. So we're going to start with the 2, and we're going to slide that over and multiply it in. So this is going to be x squared. I'm going to just go ahead and write minus 1x, and then minus 12. So I need two numbers that multiply to give me -12, but those same two numbers add to give me 1. So 1 and 12, that can't work, so that's out. So we have 2 and 6. There's no way 2 and 6 can add together to give me 1. And then we got 3 and 4. So 3 and 4 are 1 apart, so we can make that work. We just got to figure out what to do about a negative. So we need -1, so we need to make that -4. And we should be able to see 3 plus -4 does equal -1. 3 times -4 equals -12. So I'm going to come back over here, and I'm going to write them in the parentheses. So we're going to say x plus 3, and then x minus 4. Now, we did slide a number other than 1. My a value was a 2. So remember, the next step would be divide. So we're going to divide that original a back into both numbers. So my original a was a 3. Or excuse me, my original a was a 2. So we're going to divide it into the 3 and the -4. And then simplify. So 3 and 2, we can't simplify that any further. All right, -4 and 2, we can simplify that to -2. All right, so last step would be anything left in the denominator. We're going to move that up in front. So this is going to be 2x plus 3 and x minus 2. And again, if you want to kind of check this and prove to yourself, you could always multiply this back out, and it will in fact give you the same original trinomial that we started with. Okay? All right, so number 12. Oh, I have two number 12s. So for number 12, I have -3x squared minus 21x minus 54. So I absolutely have a GCF of 3 because I can divide 3 out of both of these, but that negative in front, I need to go ahead and factor that out with the GCF 2. So -3 divided by -3 is going to be positive 1x squared. -21 divided by -3 is going to be positive 7x. And then 54 divided by -3, that's going to give me -17. All right, and once I divide those out, I should be able to look at the inside piece right here. And actually, I just realized I made a mistake. Not 17, that should be 18. All right, so we're going to look at the inside, and we're going to be looking at this part right here. That GCF is still going to be part of the problem, but that doesn't mean that it actually is going to go away. But this is what we're going to factor. Now, my a value is now a 1, so even if I slide that a value over, it's not going to change that -18. So we're looking at multiples of -18 that add to give me 7. So again, 1 and 18, there's no way to get 7 from that. So then we have 2 and 9. So 2 and 9 are 7 apart. And we want a positive 7, so we're just going to make the 2 negative. Now again, remember, you can make one of them negative. You can one of the numbers negative, or you can make both of them negative depending on what you need as your numbers. So we're going to write those back in. So we're going to say -3. I have x minus 2. And then x plus 9. Do not forget that I need to make sure that whatever number I supposedly slid, which was a 1, I divide it. Now again, dividing by 1 is not going to change this problem. So we're actually done, and I don't have to finish the rest of the process for my factored form. My GCF, whatever GCF, or if you have a GCF, if you wind up taking out a GCF, that is always still going to be part of your problem. All right, and last one. So always check for a GCF. So I have 3, 6, and 24. So we obviously have a 3 for my GCF. For this one, though, I have an x cubed, an x squared, and an x. So I can actually take an x out of each of these. So we actually have a GCF of 3x this time. So 3 divided by 3 is 1. I had 3 x's, okay? So I have 3 of them, but I took one out. So that leaves me with just 1x squared. So then I'm going to say negative 6 divided by 3. That's going to give me negative 2. I had 2 x's, but I took one out. So that leaves me with 1. So that's going to be negative 2x. Then I have negative 24 divided by 3. So that's going to give me negative 8. And I had 1x right here, but I took that one of those x's out with the GCF, so I'm left with none. So again, we are going to focus on the x squared minus 2x minus 8. And there is a 1 in front, so again, if I slide that over, that's not going to change anything. So we're looking for two numbers that multiply to give me negative 8, but add to give me negative 2. So for that one, we have 1 and 8. There's no way to get 1 and 8 to work to get 2. Then we have 2 and 4. So how do we make 2 and 4 work? They're 2 apart. So I need it to be negative, so we're going to put a negative on the 4. Just check yourself. So 2 plus negative 4 does give me negative 2. 2 times negative 4 does give me negative 8. All right, so I have 3x. And I'm going to do 2 parentheses. I have x plus 2. And then I have x minus 4. Now, again, I did technically say that I multiplied the 1 over, but dividing by the 1 is not going to change anything. So I'm done with this problem. I have my factored form. Okay. And actually, I forgot to change that to a number 3. So if you will, just on your notes, if you printed these out or if you're writing them, we need to change that to number 13. I duplicated the numbers. So again, when you're factoring, don't forget when you're factoring that you've got to check or first ask yourself how many terms do I have. Always check for a GCF. And then once we do that, what method is going to be the best method depending on the number of terms and what happened when if I did have to take a GCF out. I'm going to do one more example that's got a little bit bigger set of numbers. So I got 6x squared minus 25x plus 14. So I can see that I don't have a GCF here. I'm going to take that 6, I'm going to slide that over to the 14, and I'm going to multiply that together. So if I have 6 and 14, that's going to give me x squared minus 25x plus 84. Okay, so we need to find two numbers, and we need two numbers that multiply to give us 84, so that are going to give us the a times the c, which is 84, but we need to add to get the b, which is going to be negative 25. So obviously I could do like 1 and 84. That's not going to be close enough. So then I have 2 and 42. That's not going to be close enough. So what happens when you're kind of struggling to think about what other multiples that you have? So I'm going to pull up Desmos and I'm going to just kind of start dividing 84 and see what I can find. So obviously with 3, I have 3 and 28. And we're looking for it to be 25. Well, 3 and 28 could potentially work. So let's see. So we have 3 and 28. And then 3 plus 28. So we would have to make that 28 a negative. So here's where an issue comes in. So if I do 3 plus negative 28, that does give me negative 25. But 3 times negative 28, that's not going to give me positive 81. And I need positive 81. All right, so I'm going to go back to Desmos, and I'm going to kind of see what else I can find. So we have 4. So we have 4 and 21. That could work. So we have 4 and 21. We got to check our negatives. So this time, I need to make the 4 and the 21 negative so that I can add these two together to give me negative 25. So let's check the multiplication. So I have negative 4, negative 21, and then negative 4 times negative 21 does add to give me positive 84. So I'm going to write those two. So I have x minus 4, and then I have x minus 21. Now, when we're doing this, we've done the slide. Now we need to go back and we need to divide. So we're going to go back and divide the number we slid. So the number we slid was 6. So we're going to divide that a back out so we can undo that manipulation. And we're going to simplify. So 4 and 6 are both divisible by 2. So if I simplify 4 over 6, that's going to become 2/3. We want to simplify every time. And then we have 21 and 6. So 21 and 6 are both divisible by 3. So that's going to simplify to 7 over 2. All right, and then our last step is anything left in the denominator. So we have a 3 in the denominator and a 2. So we're going to take that 3, we're going to move it up, and we're going to take that 2 and move it up. So this is going to become 3x minus 2 times 2x minus 7. Now, if you need any help with this, please don't hesitate to contact me.